Chesapeake Utilities Corporation's Florida Public Utilities needed to replace a power transformer at a substation in Fernandina Beach, Florida.
Initially, we had 2 units that were here for a long time. And the first 2 initial transformers were sister units. They were built before the 2000s. And to do this project, we had to move one transformer that was in the middle and retire it. Then the one that was all the way at the end, we slide it in and moved it in the middle position. And then the final piece of the project was to bring the other transformer that was the new one and install it at the new location. Initially, we have to create a clearance. Since it is energized, this is a very dangerous situation in here. So you have to create clearance for the contractors to be able to work in a safe environment. So we were able to isolate those 2 transformers and leave this transformer alone, serving the whole island. After that, then the rigging company has to come over, and then once we give them clearance, they have to also ground everything so that everything is isolated. Then when they hang their grounds, they have green flags that give indication to the workers that that's the area you can't go close to. And there they can begin disassembling the transformers. And once the transformers are disassembled, then they can start the rigging process, which in here we couldn't get a crane because everything is energized on that area. So that's why the only way to move these transformers was by doing some railroad platforms and sliding them out. And that's about a 160,000 pound unit that you're sliding out from the current position to the other position. Our company is safety as the number one for both our employees and our public, and we take that very seriously. You have a tailboard meeting with the employees to review what the project is going to be. Then after you all agree and are familiar, you inform them where the near hospital is, what happens if there's an incident. So once everything gets cleared out, then individuals proceed to do the work, and they all do it in a safe kind of manner. They have to use hydraulic equipment to be able to raise the unit and slide it, and it's a very slow process. It takes a while. You can't do it very quickly because you're dealing with, like I said, 160,000 pounds, and you have to be very careful. You have to make sure that the ground that you're sliding it on is going to be able to support that load. So through all those points, you have to do it very, very slowly. So they have to remove the radiators, take out the oil, and then they have to then disassemble the bushings and disconnect the ground, because every unit has to be grounded to protect everyone. I don't know if you saw me once, I touched the transformer to get to feel how it's humming. I can do that because there's enough ground in the system that allows us to feel safe and work safe. So it's a perfectly normal thing to do. Once the whole unit out, then you have to bring in the other unit, but then there's a process for that. You have to begin then assembling the unit and filling it with oil, putting the radiators, putting the bushings, making sure the gaskets that go in are properly sealed so that there's no leaks and things of that nature. And then after all of that is completed, then you go to the procedure of testing the unit and making sure that the electrical pieces are perfectly fine to be energized, because you're putting 138,000 volts on those units. Once it's all tested, then the folks in here for the control, they run all those cables in this cable trench, and they begin to connect all those cables to the relays that are here in the control house. The relays are devices that kind of monitor how the flow of electricity and current is. So you have to also ensure that the settings for the relays and everything is correct. Once you get to all those and you run the test, you do all the report and you see the health of the unit, then at that point you can make a decision to normally set the steps for energizing the unit. We write a clearance order, and the way we follow the clearance order is military kind of style. We write the instructions, I read the instructions to the IMC technician, the technician has to repeat that instruction back to me. And once you agree with that, you tell him to proceed. And then he closes the spring knob over there. And then that sends a signal to the operator over there to begin to move the arm and close. And at that point, you hear the transformer humming, and that's what you heard energize the unit. That is the most satisfying part of the whole job, meaning that you were able to energize the unit successfully. No one got hurt. And now we brought in new transformers that have higher capacity. Customers are going to be served. And it's part of our storm hardening and reliability enhancements that we do for our normal operations